Okay, here the recording in progress. So let me share the screen. All right, so we're close to being done with this section. I may actually finish today. If not, I have tomorrow. Thursday, I'll let you ask questions about anything. Our next exam is Friday. So coverage is just chapter 5. It's not that much. 5.2, 5.3, 5.4. 70% homework requirement. That's pretty easy to do considering I do a lot of the problems in class anyway. And so you should know all the rules by now, but you have to join the Zoom session. For many days, it's optional. Some of you come all the time. Some of you come none of the time. Some of you come some of the time. That's okay. But for the exam, you all have to come Friday. Camera on, true background, first and last name, just as on my row sheet, so I don't have to guess who you are. Keep yourself muted. And if you have any questions, put them in the chat. Okay. Then after that, there's only one more test. We're almost done, folks. And then next week, we have a short week. We have a Thanksgiving weekend, Thursday and Friday. And then before you know it, we're all done. Okay. All right, so we're going back to exponential growth and decay. Yesterday, we did more of the growth. Today, we'll do some of the decay stuff. Okay, so key thoughts, page 305, Q of T equals Q0 e to the KT. I've been using A, it's the same thing. A of T equals A0 e to the KT. Go ahead and put that on your formula sheet, on your cheat sheet. Okay. And yesterday we did growth problems. Something was growing, like bacteria was growing. Okay. Now we'll do decay, like radioactive decay, 5 and 6 and 7 and so on. So a substance is decaying, it's decreasing as time goes by. All right, so the first thing we have to talk about is the concept of half-life, half-life of a substance, of a radioactive substance in general. Okay. So the half-life is the amount of time needed for a substance to reduce to half its amount, is my guess. Okay. That is making the assumption that this substance decays so that at any time you can figure out the half of the amount based on how much it started with and its half-life, so-called. Okay, so I have a little chart here. So let's pretend that the half-life is 3 years of some radioactive substance, let's say. Okay, let's say I started off with 8 milligrams. Okay, the half-life is 3 years. So that means after 3 years, you have 4. Okay, the thing that's a little bit tricky, though, is you might think, oh, if it goes on to 4, then after 3 more years, that's down to 0. No, it doesn't work that way for radioactive decay. Okay, it's almost like you start afresh, you start brand new and say, okay, after 3 more years, 6 total, you would have half that amount. So now you're down to 2. Okay, after 3 more years, you have half of that, which is 1. After 3 more years, you have half of that, which is 0.5. After 3 more years, half of that, 0.25, and so on. Okay, so that's the way half-life works. Okay, at any moment in time, if you go a half-life in time from that given point, you would have half the amount. So you notice the pattern after every 3 years, you just take half the previous amount. 8 goes to 4, half of 4 is 2, half of 2 is 1, half of 1 is a half, and so on. Okay, so that would be for a half-life. Right, so now, so the problem 6, the half-life is given to be 8 years. Number 6, a certain radioactive substance has a half-life of 8 years. Okay. If a sample has a mass 200 grams, find an expression for the mass after T years. How much would it be after 15 years? How long will it take for 90% of the sample to decay? All right. So the initial amount was 200. So 200 goes right there. Half-life is 8 years. 8 goes here. The new amount is 100. You say, how did you get to 100? Half of 200. Half-life, just like this chart. Right? If you start off with 200, after 8 years, the half-life of this substance, now every substance, every radioactive substance has its own half-life. For this particular substance, the half-life is 8 years. So after 8 years, I have half of 200, 100. Solve for k. So just like last time, divide by 200. That's a half or 0.5. 0.5 is e to the 8k. Take the natural log of both sides. ln 0.5 is 8k, divided by 8. K is ln 0.5 divided by 8. It's about negative 0.0866. Let me try to show that to you on my calculator. ln 0.5 divided by 8. Negative 0.0866, blah, 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 blah. Okay. And it's a negative as we expect. Okay. What's the significance of the negative? Negative means we are not growing, but we are decaying, decreasing as time goes by. So the answer to part A is now, gives the equation A of t is 200 e to negative 0.0866 t. So now you give me a time, I can give you an amount, or you give me an amount, I can give you a time. So part B, how much of a 200 gram sample we made after 15 years? I just plug in 15. So A of 15 is 200 e to the negative 0.0866 times 15. And that comes up to be about 54.53 grams. Let me show that to you. So 200. Second function on my calculator is above the ln, so the e to the x button up here, right? So second function, e to the parentheses, negative point. Okay, now my calculator has an answer key, which kind of helps. That means I don't have to type out negative 0.086643, blah, 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 blah. If I just hit the answer button, it does it for me. So it's the answer times, what was it again? 15. So answer times 15. Let's see how I typed it in. 200 e to the parentheses answer. When I hit answer, the calculator knows it's negative 0.08664339.757. That prevents me from having to type that all in again, times 15. Okay, 54.525 rounded off to 54.53 grams of the substance is what I have. Okay, then part C. %90 of the sample to decay. 6C there. Now, 90% decay means 10% is left. Or 20 grams left, right? I started with 200. 90% gone, 90% decay means 10% left. So what does that mean? 20 grams are left. So my new amount is 20. So 20 equals 200 e to the negative 0.0866 t. Divide both sides by 200. 20 divided by 200 is 0.1. 0.1 equals e to the negative 0.0866 t. How do I get rid of e? ln. After a while, it's the same stuff. Cancels out. ln 0.1 is that. Divide both sides by negative 0.0866, and I have my answer. So t is natural log of 0.1 over negative 0.0866. Evidently, it's about 26.59 years. And by the way, you should label your answers. I will take off points if you don't give the units. If you just say 26.59, well, it makes a big difference if that's seconds or minutes or hours or years, right? Okay, so it's years in this particular case.
And do you always want us to round to 2 decimal places?
So I round around for something like this to 2 decimal places. For the final answer, yes, that would be fine.
Okay.
Okay. For intermediate values, you should give technically every single digit is greater accuracy. So I really should put, but you know, we're all too lazy to put, you know, negative 0.08664339.757. You know, it's too cumbersome to write that whole thing out. Okay. Now, you know, we're students, we're learning this stuff. I can let you get by with it. Okay. If you were in a actual job that required, super duper accuracy, then you would keep every single digit. Actually. Okay. So let me see if I can show you this. ln.1. Remember, some of you, your calculator automatically gives you a left paren. Then you have to close it with a right paren. So 0.1. So that means you folks have to close it first, right? And then divided by what? It's slipping off there. Divided by negative 0.0866 right here. Okay, so divided by negative. Again, watch out for the negative symbol on my calculator. It's down here, not this one. Okay, so how can you tell? This is with 4 basic arithmetic operations, right? Plus, minus, times, divide. So this minus sign is for subtraction. And this is the one that gives you the negative number, at least on my calculator, but I'm sure many calculators are similar. There's a good chance your calculator does the same thing. So this minus is the plus, minus, times, divide, but this is the negative number. So what do I want again? Negative 0.0866. 0.0866. Right. ln 0.1 divided by negative 0.066. 26.5. So ln parentheses 0.1 divided by negative 0.0866. 26.588. I rounded out to 26.59 years. Okay. Now, number 8, there's really not much to do. You just have to think about what's going on. A culture of bacteria doubles after 4 hours. What proportion of the original number of bacteria will be present after 8 hours and 16 hours? Okay, it doubles after 4 hours. So 8 hours, it doubles twice, right? So 4 hours, double. Another 4 hours, double again. So you've doubled a double. You had 2 doublings, so that's 4 times the original. So the answer to 8A is 4 times the original. How about B? 16 hours. Well, let's see. How many doublings, so to speak, if I can coin such a term? I'm not sure if that's a real word, doublings, but how many doublings are there after 16 hours? Okay, doubles every 4. That's 4 doublings, as it were, right? So 1 amount grows to 2, 2 goes to 4, 4 goes to 8, 8 goes to 16. So the answer to B is 16 times the original. Okay, so once again, 8A is 4 times the original. B is 16 times the original. I'm not sure if I can write that. Maybe I can sneak that in here. 4 times original. I'm writing my book here. 16 times original. Let's sneak that in there. Because it's doubled 2 times, right? After 4 hours, double. After another 4 hours, or 8 hours total, another double. So you've doubled a double, that's 4 times. Okay, part B, so double, 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 right? 4 hours, 8 hours, 12 hours, 16 hours. So the first doubling is twice the original, double again 4, double again 8, double again 16. So the answer to 8B is 16 times the original. So this says 4 times the original. I'm not sure you can see the 4 there. That's a 4. 4 times the original and 16 times the original. Okay. So continuing down to evens, because you don't have the even answers, I'll let you do the odds on your own. So again, homework-wise, what was it? So it was 1 to 16. All. Okay. Yeah, it's a mean trick. You don't have the even answers, but I'm doing the evens now anyway. Okay, 10. Find the half-life of a radioactive substance that decays by 5% in 9 years. So find the half-life. Now, decays by 5% in 9 years means you keep 95% after 9 years, right? You lose 5%, so you keep 95%. So here's what you do. A of t is A0 e to the kt. 9 years, so 9 goes here. And then here's the tricky thing. 95% of the original means I put 0.95 A0 right here. That's 95% of the original. By the way, you say, they don't give me the original amount. That's true. You don't need it. This can be done irregardless of the initial amount. So you could start off with 1 gram, you could start off with 1,000,000 tons. The problem would still be the same. Right? So decay by 5% means keep 95% of A0, right? You lost 5%, so I keep 95%. 0.95 A0 is A0 e to the k times the time, which is 9. Notice very conveniently divide both sides by A0. As long as A0 is not 0, you're not allowed to divide by 0. But it's like, wait a minute, if there's 0, there's nothing to talk about. We have no discussion, right? There's no substance there. It's got to be a positive quantity. So you can divide by A0, and that kind of proves to you it doesn't matter what A0 is, strangely enough. So you will get the same answer if you had 1 milligram or 1,000,000 tons. Okay, so the rest we've seen that game before. 0.95 is e to the 9k. Take the natural log of both sides. ln e cancels out. ln 0.95 is 9k. Divide by 9. K is that. Negative 0.005699. And yeah, getting back about the rounding off, in between the final answer. Now, my final answer, I put round to the nearest 100, but in between steps, keep as many digits as possible for accuracy. Okay, so I'll show you ln 0.95, divide that by 9. ln 0.95 divided by 9, negative 0.005699, blah, 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 blah. I went out to here for greater accuracy. So that goes over here. A of t is A0 e to the negative 0.005699 t. Now it asks, what is the half-life down at the bottom there, number 10? Sorry, I have to raise up the book because I can't straighten it out. It's hitting the neck of the document camera. So I have to make it crooked. Half-life of the substance. So now what do I do for the half-life? So I have this equation. Half-life means 0.5 the original. Instead of 0.95, I just make it 0.5. Try to get this in focus here. There we go. So 0.5 A0 equals A0 e to the blah, blah, blah t. In case you're wondering, yes, it's fair game. If you even want to put a sample problem on your cheat sheet, you're allowed to. So no, I'm not sure I remember, did I do this and this and this, right? Oh, this goes here, E goes here, ln does that. I forget what to do. Put a sample problem on your cheat sheet. You're allowed to do that. So then when you get something like that on a test, you can say, now what did we do? Oh yeah, we did this and that and the other thing, right? So 0.5 A0 equals A0 e to the kt. And notice again, you can just cancel out the A0. You divide both sides by A0. So it's the same thing as over here, right? So just cancel them out. Don't need A0 anymore. As long as A0 is not 0, which it isn't, because if there's nothing there, there's nothing to decay, there's no radioactive substance, we're not talking about it anymore. So I have 0.5 equals e to the kt. How to get rid of the e? ln. Same old stuff. After a while, it's repetition. You're just doing the same thing. So this cancels out. ln 0.5 is negative 0.005699 t. Divide both sides by negative 0.005699, and you get your answer, which presumably is 121.62 years. And let me try to show that to you. Let me show it to you on a regular scientific calculator, the backwards type of calculator. So this kind, you actually have to hit it backwards, which means 0.5 ln. So let me get 0.5 first, and then ln. So some of you have a backwards calculator. You have to hit the number and then ln, which is over here. And then I'm dividing by what? So divided by 0.005699. And this kind of calculator, you have to hit this plus minus button to change it to a negative. So right now it's a positive. So you hit the number first and then hit this thing, and then negative pops up. Okay, then I press equal. And there it is, 121.626, whatever. 121.62 years roughly. Okay. Okay. 14. If $25,000 is invested into an account that returns 7% per year compounded continuously, how long will it take for the investment to double and to triple? Okay. It's important. So you're raising money by interest. So this is the growth situation once again, right? You're investing, you put money in the bank and you hope it gains interest. And you want your money to double, you want your money to triple. How long does it take? Assuming you can get 7% compounded continuously. Okay. So 25,000, K is 0.07. You want to double and you want to triple. Okay, so $25,000. It said double. Well, what's double 25,000? 50,000. Divide by 25,000. 2. 2 equals e to the 0.07t. Interest rate was 0.07. Okay. Take the natural log of both sides. After a while, you're just doing the same stuff. ln2 is 0.07t. Divide both sides by 0.07. 3.35 years, it says. So let me try that. ln2 divided by 0.07. I did it wrong. I don't know where I got that. 9.90 years, almost 10 years. That seems more reasonable. I made a mistake last time. ln2 divided by 0.07. 9.90 years, almost 10 years. That seems more reasonable. Now, triple. How would this problem change? Instead of ln2, ln3. Everything's the same. Maybe I'll sneak that in here for you. If you think about it, you would put 75,000 here. After you divide it by 25,000, there'd be a 3. So part B, I'll just put here would be natural log of 3 divided by 0.07. So triple, you would put 75,000 here. After you divide, you have a 3 on the side. All the algebra is exactly the same. Instead of ln2, you have ln3. And what is that? ln3 divided by 0.07. 15.69 years. $15.69. All right, then the last even problem is 16. Then I'm done, folks. Okay, and then tomorrow I can start giving you my own review problems for the preparation of the test. See where to go. The parents of a 3-year-old child put $20,000 into an account with the hope that the amount will grow to $120,000 when the child starts college in 15 years. What rate of continuously compounded interest is necessary for this goal to be met? Okay. So I start with AFT is A0 e to the KT. And it says they're starting with 20,000. The initial amount is 20,000. They wanted to grow to 120,000. So 20,000 here, 120,000 here, e to the k t, and the time is 15 years because the child is 3 years old now. So in 15 years, they'll be 18, ready to start college. All right, so divide both sides by 20,000. That's 6. 6 equals e to the 15k. How do I get rid of the e? ln. ln 6 equals 15k. Divide by 15. So k is ln 6 over 15. 0.1195, but if you're giving your answer as a percent, you would say 11.95%. Okay, and let me show that to you. Again, those of you that have a calculator that automatically pops up with a left paren, I'll show you that. So for you folks, if there's a left paren that automatically pops up, then you need to close it. So ln 6 needs to be closed. And then what? Divided by 15. So divided by 15. And there we go. 0.11945, blah, 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 would round off to 0.1195. So 0.1195 or 11.95%. And there we go.
So we wouldn't be expected to round it to 12.
Around at 12, no. In fact, that's normally what happens in banks. In banks, they would round off to the nearest 100th of a percent. So I hear,
all right,
yeah,
cool.
I definitely hear 11.95%. I don't usually hear 11.953 or something like that. So yeah, we'll just leave it like this. The last thing is to show you on this type of calculator, the backward calculator. So with a regular scientific calculator, you folks have to hit 6 ln. So 6 and ln over here. Okay, there it is. And then divided by what? Divided by 15. So divided by 1.5 equals, and there we are, 0.1194, blah, blah, blah. So 0.1195 or 11.95%. Okay, guess what, folks? We are done with the chapter. It's only Tuesday. And that's it. In fact, it kind of fits exactly because all I had left were buffer days. Tomorrow I'll do my own review, but I may leave you some time for questions and answers. And definitely Thursday, the 18th, question and answers, and the exam will be on Friday. Next slide. Okay. All right, let me check the chat. There's something there. So got a request for 5.3, 21, and 41. Let me see if I'm going to do that now. Or it may be on my docket for tomorrow too, I'm not sure. If I have it, then I'll have to do it tomorrow. 5.321. Like this. 21. 41. Okay. 21. Element of 2x cubed over x plus 4 squared. 41. ln 2 plus ln x plus 1 equals natural log 4x minus 7. Okay. Okay, this is a product. So ln of the first plus ln x cubed. And this is division, so minus ln x plus 4 squared. Get this into focus here. Okay, ln2 plus ln x cubed minus ln x plus 4 squared. And then all the exponents can come down. So that has no exponent. 3 comes down, 2 comes down. This goes here, this goes here. So natural log of 2 plus 3 ln x minus 2 natural log x plus 4. ln stands for natural log. I'll say it every now and then just to remind you of that, but most of the time I would say ln. It's easier.
What got me confused about this problem is like my first the first thing I did was made it into a subtraction problem, but then why like is there some rule that like I'm missing, like where you like it's like for ln 2x cubed, like I changed it to 3 ln 2x and then I separated it, you know, into a addition problem.
Okay. In this situation, you're not allowed to take down the 3. It would have to look like this. Then you can bring the whole thing down. Okay. As it stands, the 3 is only applied to the x, not the 2. So that's why the 3 comes down only here and not to the 2 also.
That makes sense. Thank you.
Welcome. Okay, this one, there's a plus here. So I multiply ln 2 times x plus 1 equals ln 4x minus 7. Turn that into multiplication. Then exponentiate to get rid of the ln's. And I don't think I have to say anything else. The rest is very easy. So 2x plus 2 equals 4x minus 7. Just say, etc. You can finish that. The only thing to watch out for is if your answer comes out to be negative, but I don't think it's negative. Let's see. It's a positive quantity. So it looks like we're good. So let's say it comes out to be -5, then I'd have to throw it out because you're not taking the ln of a negative. But I think it comes out to be, what, 9/2, I think, or something like that. Why don't I just finish it? So subtract 2x, add 7, 9 equals 2x. Right, add 7 to both sides. Subtract 2x. Yeah, x is 9/2. And that's positive, and let's see, that's going to be positive. So it looks like we're good. Okay, so I think I've caught up. Let me check the chat. Any other questions, please? Check the chat. Okay, I think I've got that. All right, so anything else? Otherwise, we're done. Tomorrow, I'll make up my own review questions, and at this time, I'll let you ask questions. We still have Thursday for that also. All right, we're done, folks. So have a good day, and we'll see you next time. Okay. All right, bye, everybody. Thank you. Bye.